All right, so this is part 2 of the video on the laws of exponents, okay? So make sure you've watched part 1, which goes through all these different properties for how to deal with exponents, okay? And we're going to go through quite a few problems here. I think we've got 15 different examples just to kind of go through all the different properties you might use, okay? Now, the great thing about the laws of exponents is there's no like set order of operations for how to deal with these, okay? In many cases, there's multiple things you could do that will still get you to a final and correct answer. Okay, so don't feel like there's a set order of operations for using the laws of exponents, because there's not. Okay, so look at number 1 and 2. They look like they might be the same problem, but they're not. Okay, in number 1, the 3 is being raised to the 4th power. We don't think of this as a negative 3. We think of this as the opposite of 3 to the 4th power. Okay, well, 3 to the 4th power is 81, so the opposite of that is negative 81. Okay. If we add parentheses around the negative 3, it changes everything totally, okay? In this case, we're raising negative 3 to the 4th power, okay? So it'd be negative 3 times itself 4 times. Well, we've got an even number of negatives, which makes my answer positive, so this one would be positive 81, okay? There's a very small difference between these two, but this difference leads to a lot of mistakes, okay? If you don't have parentheses here, the negative is not being raised to the 4th power, just the 3. So be careful when you see these types of problems, okay? Number 3, we've got a negative exponent, so we can take the reciprocal of this 1/3 and change the exponent from negative to positive. So 3 over 1 to the 1st power is just 3 to the 1st power, which is 3, okay? Number 4, anything, this whole quantity is being raised to the 0 power. Anything to the 0 power is 1, okay? So there's 1 through 4. Let's look at 5 through 8 now, okay? Number 5 is a lot like number 3 here, okay? There's just a little extra step that we have to do at the end, okay? So I want to flip the x over 5, okay? Make it 5 over x. The exponent changes from negative to positive. Now I've got a quotient raised to a power, so each part of this quotient has to be raised to the 3rd power, so 5 cubed over x cubed. And I can simplify that. If I can, I need to, so it's going to be 125 over x cubed. Okay, so the answer is highlighted there. Number 6, we've got a product of powers here. The base is the same, so I can just add those exponents. Okay, and that's going to give me x to the 8th. Okay, number 7 is the same type of problem, but I'm going to have to add a step. I'm going to add those exponents, which gives me a negative exponent z to the negative 4th. I can't stop with a negative exponent. So I need to, what we call, move that through the fraction. This z was in the numerator. I'm going to move it to the denominator, and the exponent changes from negative to positive. So the answer for 7 is 1 over z to the 4th, okay? 8 here, I've got a quotient of powers. Remember, I can, if the bases are the same, I can subtract the exponents. So it's b to the 6 minus 3, which is b cubed, okay? All right. Pause the video if you want to here, and then kind of work these last 7 problems, and then come back and check your work, okay? All right, number 9 is a power raised to a power, okay? So we can multiply those exponents. 4 times 7 is 28, so my answer here is a to the 28th power, okay? 10 is a product here. We've got the product of these 3 terms, negative 2, x, and y squared. All of those, each of those 3 terms needs to be raised to the 4th power, okay? So that means negative 2 to the 4th power. Notice the parentheses here, they have to be there. X to the 4th power, and then y squared to the 4th power. Well, we can multiply these exponents, 2 times 4, to get 8, okay? Clean up this negative 2 to the 4th power, I get 16, and then push everything together there. So the answer is 16, x to the 4th, y to the 8th, okay? 11, again, quotient raised to a power. That's going to give me c cubed over 4 cubed, which is c cubed over 64, okay? Number 12, I've got 2 different quantities here. This first one's not being raised to an exponent. There's an understood exponent of 1 there, okay? It's not there because it doesn't need to be. So that's not going to change. What is going to change is each of these 3 terms is going to be raised to the 3rd power. So this piece right here, okay, is a lot like number 10, okay? So 2 to the 3rd power, that's where this 8 comes from. A to the 3rd power gives me a cubed, and b to the 4th raised to the 3rd power. I'm going to multiply those exponents 3 and 4, and that's why the 12 is there, okay? Now, I can multiply these two quantities together. I've got 5 and 8, so I'm going to multiply those together. I've got a cubed and a cubed. They have the same base, so I can combine those, and then I've got b squared and b to the 12th, okay? I'm going to be adding those exponents because we're multiplying a times a and b times b, okay? So 5 times 8 is 40. A cubed times a cubed, add the exponents, 3 plus 3 is 6, and then b squared times b to the 12th, add those exponents so we get 14. All right, 13. I need to clean up this piece. I need to clean up this piece, and then I'm gonna use my laws of exponents to combine those, okay? So I'm gonna cube both of these, and then I'm gonna raise each of these three terms to the 4th power. Okay, so multiply the exponents. 2 times 3 is x to the 6th. Y to the 3rd is just y to the 3rd. Multiply the exponents here. 3 times 4 is 12, so that's y to the 12th. X to the 4th, and then z to the 16th. So this should be z to the 16th. Now, I can multiply these together. So x to the 6th times x to the 4th is going to give me x to the 10th. There's no other y term in the numerator, so I'm going to leave that there for now. There's no other y term in the denominator, so I'm going to leave that there for now, and then z to the 16th, okay? Now, these two have the same base y, so I can subtract those exponents, which gives me y to the 9th. That's going to be in the numerator. So x to the 10th, y to the 9th, over z to the 16th. Okay, so that's the answer for 13. All right, now on to the last two. So 14, this is one of those you can do a lot of different ways and still get to the right answer, okay? So I'm going to use a couple of different rules here that maybe you would use, and that's okay. Work the problem the way you think you need to work it. Follow the steps that I decided to use, and then, you know, maybe your way's better, maybe my way's better, but either way, you're going to see how the rules can be used in different orders and still get the same answer, okay? So first thing I want to do, I'm going to do the following. So 27 over 3, that simplifies to 9, okay? These negative exponents, I'm going to go ahead and move them through the fraction and make them positive. So this b to the negative 3 went up to the top and became b to the positive 3. This a to the negative 2 moved down to the denominator and became a to the positive 2, okay? Because these were both positive exponents, I decided just to go ahead and subtract. They have the same base c, so I subtracted 5 minus 7 and got c to the negative 2, okay? So there's 3 things I have to do to finish simplifying this. The 9 is done. There's nothing else I can do with that 9. In the numerator, these b cubed, I can add those exponents and get b to the 6th. This c, because it has a negative exponent, needs to move through the fraction to the denominator and become c to the positive 2. And these a expressions here, they have the same base, so I can add those exponents, and get positive 7. So my final answer should be 9 times b to the 6th over a to the 7th c squared, okay? It helps if you've got different bases to write those in alphabetical order. You don't have to, but if you'll notice on all of my answers that have multiple variables, they're in alphabetical order. That's just a good policy to have, okay? 15, last one. Again, different orders that you can do here. I'm going to go ahead and flip the expression in the parentheses here. So the 2z squared goes to the numerator, the y goes to the denominator. That changes the exponent from negative 3 to positive 3. Now I'm going to raise each of these 3 terms to that 3rd power, okay? So it's 2 cubed, which is 8. I'm going to multiply these exponents. 2 times 3 gives me z to the 6th. And an understood 1 there, that's y to the 1st power. Multiply that 1 and that 3, and I get y cubed. So the answer for 15 is 8z to the 6th over y cubed, okay? So that's a lot of different examples that give you a pretty good idea of how to use these laws of exponents.